Oh, wait, you're listening?
Okay.
All right.
Okay.
All right.
You're
Listening
to Radiolab.
Radiolab.
From
WNYC.
See?
Yeah.
Hi, Latif.
Hello.
All right. So, reporter walks into a bar.
Okay.
And that's just the beginning of our story. That reporter's name is Rachel Gross. She is 35. The year is 2024. It's a warm spring night. The bar is in Brooklyn, and it is called the Branded Saloon.
So, Branded Saloon is a very gay bar. You know it because there are all these rainbow flags bursting out the front. It's like very, very crowded and loud.
She's a regular, shows up there nearly every Thursday to hang out.
Like grab some fries, hang out for an hour.
But also for karaoke. So that night she made her way to the back room.
Got on stage, put in like a Savage Garden song, Crash and Burn, from like my teenage years. Do you know this one?
I don't. Can we pull it up really quick?
Yeah.
Okay, Crash and Burn, Savage Garden. Okay. Okay, we got that. Oh, I do know this song. Oh, okay, yeah. Okay, so you're singing along.
And I think it was initially going fine, but it's really at the chorus that just like nothing came out of my mouth. It was just air.
Could you almost imitate what happened?
Yeah, it goes like, when darkness is upon your door and you feel like you can't take anymore.
Is it like when you have a sore throat and suddenly you're just like, oh, I can't, there's nothing coming out? Or did it feel different?
No, it was, the notes weren't translating from my brain to my vocal cords. And the rest of the song, like the verses, I just felt like I wasn't on the beat.
But you finished it out. You finished out the song.
Yeah, I mean, I am used to bombing. It's part of my philosophy of karaoke. It like teaches you how to be okay with things not going perfectly.
Yeah.
So I was trying to like keep that in mind while I was like, damn, what just happened? I literally crashed and burned.
And that night when she got home, Rachel started thinking about another moment from the day that was a little strange.
I was like shadowing an acupuncturist because I was writing about alternative medicine. I'd take like handwritten notes and my writing was so poor, I couldn't read it afterwards. So that was another like, odd. But Friday, I felt myself to be slurring a bit. And then on Saturday, I decided to go for a run, and it felt really weird. It felt like I was like forcing my limbs to run in tandem. It was after that run that I decided I needed to go to the hospital. I remember they handed me the form that you just fill out with your basic information, and I couldn't fill out the form. Like, I couldn't write my name and birth date.
Wow.
They do a CT scan, and the PA comes up to me, and he's like, honey, you have a bleed in the back of your brain.
In other words, she'd had a stroke.
And that's when I went into shock.
So they rush her across town to a hospital that has a stroke ward.
There's like a lot of beeping. Most of the patients are over 70, of course. The neurologist and all her residents come in, and they eventually said, we think this is a cavernoma. It's like where very small blood vessels form a little like raspberry. And this little raspberry can exist your whole life, but sometimes it bursts. And that's when you have a stroke. And in my case, doctors were saying you should probably have surgery to remove it.
And where exactly in the brain was the stroke?
In the cerebellum.
And where is that? What is that?
I didn't know what the cerebellum was at that point, but the neurosurgeons told me that it's in the back of my head, basically behind my neck, and it's involved in fine-tuning motor stuff. They also called it redundant.
Redundant?
And later, one of them called it practically vestigial.
It almost sounds like an appendix, like...
Yeah, exactly. Another one said, like, because I was terrified about surgery, obviously, he says, like, you can actually take out, like, a third of it and people don't even notice.
What?
He was like, when you wake up, you might feel a little bit clumsy, but you'll still be you.
Huh. Was it kind of like this is of a place to have a brain situation, the cerebellum's a lucky spot?
Yes. Yes, that was definitely reassuring because
So Rachel went into surgery. They removed a piece of her cerebellum. And then when she woke up, she started like testing herself.
And so I drew a spiral and it was smooth and it didn't tremor or whatever. Within a few more days, I was like circling the hall by myself and nurses were like clapping for me.
Oh.
So I was like, I'm going to have the best recovery they've ever seen.
So you're like writing, check, walking, check.
Yeah.
Like stuff's coming back. You're like, okay.
Yeah.
But over the next couple of months,
I could just still hear that slur so much. It bothered me so much. And I tried singing along to a couple karaoke tracks and I couldn't get the timing right, let alone the notes. But then the other experience I was having was a sentence that I want to say will just kind of disappear or escape me. And I will laugh at something, but it'll come out like too big or too like rambunctious. It felt much more profound than you're having some body coordination issues. That's like kind of what I'm trying to figure out now.
So Rachel Gross is actually a science journalist, and she writes a lot really beautifully about the body.
Right. Yeah. I know her work.
Yeah, she wrote this awesome book called Vagina Obscura.
Terrific book.
Mm-hmm. And so when she told me she wanted to talk, I figured she was going to tell me a story full of fun facts about this other body part. But as we sat there talking,
And I need to just go for the nearest word.
it became clear she was in the middle of a story.
That's a difficult thing to accept for someone who's like used to writing precisely.
It was still unfolding.
There's this confrontation with your sense of like who you think you are.
So I guess like, what do you really want to know? What are you after?
Yeah.
What do you want to find out?
I think the like simple quest is I want to figure out how to get my karaoke back. But that's not the bigger thing. I think my question now is, why does this feel like more than just a motor problem, more than just like fine tuning? Why do I not feel like myself anymore?
So after that conversation, Rachel just started digging in, researching, talking to so many people, reading so many studies. Producer Sindhu Gnanasambandan and I joined whenever we could.
Yeah.
And what Rachel discovered is something I thought we were done finding, which is something totally new about the basic anatomy of the brain, and a shift in how we think not just about this part of the brain, but really about thinking itself.
All right. Okay. This is Radiolab. Here we go.
Here we go.
Okay, so I started in kind of the most obvious place. What do we know about the cerebellum?
So cerebellum is the old Latin term for little brain.
Little brain. Okay.
And it's tucked in under the big brain, sitting in the back of the brain.
So I ended up calling this scientist named Jeremy Schmahmann.
I'm a neurologist at Mass General Hospital.
He's been studying the cerebellum
4 decades now.
his whole career.
Yeah.
So can we just back up and
Okay.
like, what does it look like?
Well, it's smaller than the rest of the brain in terms of size,
It's about the size of your fist.
but it's very deeply folded. Unlike the big folds of the cerebral hemispheres, everybody knows those pictures, the cerebellum has multiple tiny little folds.
And it even lives in its own like membrane pocket. So it really looks like a little brain underneath the big brain.
And the cerebellum was described in 1776 in terms of its structures by this fellow called Malacarne. And then some 50 years later, people start to look at what cerebellum does.
So by the 1800s and early 1900s, scientists are doing these experiments where they basically remove the cerebellum from pigeons and cats or whatever, just to see what happens.
Okay.
But then in World War I, you actually end up with this massive, unintentional human experiment because of the helmets that the British soldiers were wearing. So maybe you've seen pictures of this, but These helmets, they sit up at the top of the head, kind of like an upside down bedpan.
Yeah.
And they essentially leave the whole back of the neck exposed, right where the cerebellum is.
I see.
And the doctors who were fixing up these soldiers noticed that all of them sort of had the same problem. They would stumble around when they tried to walk. They were really jerky. They would fumble when they tried to reach out and grab for something.
Yeah.
In other words, they had
difficulty with the coordination and the timing of the movement.
So at this point, science basically concludes,
This is all about motor control.
What the cerebellum is doing is all the stuff in the background that you don't even think about when you're moving around in the world.
That's correct.
And that fits really neatly into the map that we were starting to make of the entire brain, where there's kind of this upstairs part, the cerebrum, which is where like poetry and art and math and all the things that make us human are happening. And then you have sort of the downstairs, the basement, where we're just sort of doing basic body stuff, animal stuff, like movements, breathing, and heart rate.
Right.
And of course, what science is interested in is all of that thinky human stuff, to the point that even today, if you look at most neuroscience papers that say that they're exploring the whole brain, they tend to just ignore the cerebellum completely.
Wow, really?
They literally crop it out of their findings. There are MRI machines that don't cover the cerebellum.
That's crazy.
Yeah, and that's probably why all the surgeons I was talking to when I had my stroke were telling me not to worry. The cerebellum is really just making you less clumsy, and it's really not going to be a big deal if we take a little bit out.
Well,
But
almost everything that you've told me was the understanding of the doctors that you've spoken to is outmoded, old-fashioned, and predominantly incorrect.
Oh.
Where we are now is a complete paradigm shift. There's been a revolution in our thinking about the cerebellum.
And can we just back up to where that shift started for you personally?
As a resident in the neurological unit of Boston City Hospital,
This was in 1982.
I saw a patient with a stroke in the basal ganglia.
And remind me, what's the basal ganglia?
Yeah, the basal ganglia are these structures that are deep in the brain. And just like the cerebellum, they've been associated with motor control. But this patient
Wasn't aware of the left side of space.
he was having problems with his perception.
And that's a syndrome that had been exclusively described in people who have damage to the cerebral hemisphere.
Like the upstairs thinky brain.
So my question was, well, if this motor system can produce a cognitive change, what about the big motor system downstairs? What about the cerebellum? So I had to go back into the stacks of Harvard Medical School's Countway Library.
So he's there in the dusty stacks and he's poring through papers for any little footnote or mention of the cerebellum. And he found
This subterranean kind of hidden description of cerebellar damage in people whose behaviors were a little off the beaten track, whether it was mental or emotional or cognitive, but it really got hidden in the literature.
Everybody knew that the cerebellum controlled motor function.
And one of the people I came across in my reporting was a scientist named Henrietta Leiner.
And that was it, motor function, you know. They're still teaching that, I think.
This is an interview of her talking about the cerebellum before she died.
When I first proposed the hypothesis about the cerebellum,
She'd been arguing that the cerebellum was actually influencing cognitive functions in the upstairs brain.
the reviewer, the peer reviewer of the paper, turned it down with the comment, this couldn't possibly be true or we would have thought of it long ago.
But, you know, science gets driven by people who have powerful influence. And those folks who were saying this is motor control won the day.
And you, I guess, did you start to look into that? What was your next step?
So we started looking at the anatomy of how the upstairs brain talks to the downstairs brain.
Because Jeremy figured that if the cerebellum is doing more than just motor stuff, then there would need to be some sort of like infrastructure between the two.
So in other words, does the cerebellum have access to information that is beyond motor control information?
So Jeremy and his mentor, Dr. Panya, this was in the late 80s, they took rhesus monkeys and injected their cerebrums, or the upstairs brain, with these dyes that act like tracers.
tracers that get picked up by the nerve cell.
Then they left the monkeys for a week or so, just going about their day, thinking monkey thoughts. And meanwhile, these dyes
Travel down the nerve, and they end at the point where the nerve ends.
And what Jeremy ends up seeing is these lit up highways going down to the cerebellum.
From areas of the brain relevant for executive control functions in the frontal lobe, awareness of ourselves in the environment, the parietal lobe, temporal lobe involved in language processing, the gyrus for emotional modulation. Am I getting too sciencey?
No, we love it.
It's called Radiolab, you know?
So all those areas send information into the cerebellum. And then other investigators showed that the cerebellum sends information back up to the thinking brain. So now, in a word, you have an anatomical circuitry linking cerebellum to the thinking brain.
Yeah. The neocortex and the cerebellum are massively interconnected.
And according to evolutionary biologist Robert Barton at Durham University in the UK,
there seems to be a very particular evolutionary relationship between these two structures.
These connections between the thinky brain and the motor brain might actually be a big part of the story of how humans became humans.
Huh.
One of the really popular ideas about brain evolution is predominantly a story of the expansion of the cortex. But we made two discoveries that kind of started to challenge that conventional wisdom.
So what he and his colleagues did was gather up a bunch of data about the size and the structure of the brains of a bunch of different primates.
And then if you know how those species are related to each other, you can reconstruct patterns of evolutionary change.
Interesting.
So the first thing Robert notices is that
across all of the primates,
their cerebrums and cerebellums are evolving in lockstep.
They're pretty tightly coordinated. But then we stumbled on a pattern in the data that took me by surprise, which was that when we get to the apes, the ape part of the story, we see a deviation from that general pattern of coordinated evolution.
Huh.
What we see in the apes is an acceleration in the expansion of the cerebellum.
Wait, so you're saying like the cortex got bigger, but the cerebellum
It got big faster.
Wow.
Crazy.
It's kind of outstripping it.
So what Robert is really saying here is that right at the moment that we are becoming human, which everyone has assumed was all about the upstairs brain, it was actually the cerebellum, so the lower brain, that was rising to the moment.
Yeah, exactly.
To the point where in the human brain today,
although it's a lot smaller than the neocortex, it has about 4 times more neurons.
What? That's a lot.
Isn't that bonkers?
The cerebellum has about 80% of the brain cells that we have.
Wait, 80% of the brain cells of our whole brain are in the cerebellum?
right?
There's a lot of brain in there.
And that's the part they cropped out of the MRIs or whatever?
Exactly.
But here's the thing that's remarkable. Most of the cerebellum, in terms of the size of cerebellum, is the region that is interconnected with thinking brain, not motor brain.
Wow.
Most of the human cerebellum has nothing to do with motor control.
So to collect what we have here,
Yeah.
there are old case studies where people with cerebellum injuries, it's more than just a motor problem.
Yeah.
Ape and human cerebellums are bigger than other primate cerebellums.
Exactly.
Right, and it's massively connected to the rest of the brain.
To the thinky parts.
Yeah.
Okay, so I still do not understand, what is this thing even doing?
I mean, that's the 80 million neuron question, or the 80 billion neuron question.
And we will get to that right after this break.
Okay, Latif,
Lulu,
Radiolab.
we are back talking about the cerebellum, this little part of the brain down near the neck that for a long time was believed to be distinctly about motor stuff, smoothing walking, smoothing handwriting, until very recently scientists began noticing that this part of the downstairs brain was wired up to the big brain upstairs, where, all kinds of behaviors like speech and decision-making and emotional regulation are processed.
Right. But the question for Jeremy Schmahmann at this point is, what is it actually doing?
And I remember presenting the anatomy of this story at one of the neuroscience meetings. And a well-meaning senior colleague said, you're telling us that the cerebellum is involved in behavior. Well, what kinds of behavior? And I really couldn't answer the question. I wasn't sure. So we did what we do in clinical neuroscience. We went to the patient, and I met a young woman in her early 20s.
She had slipped on some ice and fallen backwards and hit her head.
It was just a slip and fall, but she had a CAT scan, and they found a tumor in the midline of the cerebellum.
Oh, my gosh.
The tumor was taken out, and she did fine.
Great.
From the motor perspective. But what was noted right from the get-go by the nurses in the ward is that she had difficulty coming up with words or using words correctly. She had difficulty with planning and organizing her thoughts, and she'd had a change in her personality.
Like what kind of change?
She was being disinhibited. She was disrobing in the corridor. She was being rude to her parents. She was hiding under the bed covers. She was talking in a high-pitched kind of whiny tone of voice, which was a change for her. But this came from cerebellar damage. The brain upstairs was fine. And we then...
Since then, he's had dozens more patients
who'd had cerebellar-focused damage.
And they all have different problems with their motor and cognitive and behavioral skills. So what he thinks now is that...
Cerebellum is doing, we think, for the non-motor functions, what it's doing for motor control.
The cerebellum is doing the same thing for our cognitive processes as it's doing for our body.
Yeah, it's using the same kinds of neural circuitry to do those things.
Wait, but what do they even mean by that?
Well,
so
when you reach out to hold something or to reach something.
Both Jeremy and Robert Barton walked me through what the cerebellum does when you, reach out to grab something.
Think about reaching to grasp a piece of fruit.
Although Robert wanted to talk about fruit.
You're reaching out for that cup of coffee.
And Jeremy was all about the coffee.
Okay.
Anyway, with either one, what the cerebellum is doing is figuring out the exact right sequence of moves that you need to make. How to move your arm the right distance.
How far it is.
So you don't overshoot or undershoot.
How fast to move your hand.
How to time that with the position of your hand.
As you reach out to hold the cup.
How much force you're using to gently bring it back to your mouth.
Bring it to your lips so you can drink from the cup.
Or if it's a piece of fruit.
You're going to manipulate it in a certain way that will end up with, a nice mouthful of food.
Either way.
That involves a certain degree of planning of movements and adjustment of your movements as you move your hand in space.
And that's what the cerebellum is doing. It's like an invisible orchestra conductor doing all the real-time, unconscious, behind-the-scenes adjustments to plan, sequence, and time all the elements of that action.
I see.
And it's not a huge sort of leap from that to think about the mechanisms that might be involved, for example, in organizing any kind of sequence, including a sequence of vocal utterances.
Anything from speaking
to produce a well-articulated sentence.
To forming a coherent thought.
Absolutely.
Those things also require the same organizing and planning and sequencing and timing. So the argument here is that the cerebellum is also the invisible conductor of your thinking.
It's doing in the same way that kind of information processing to language processing and mental manipulation of information.
So you're talking to someone at a party, you're telling them about your day.
Yeah.
And you're kind of deciding what parts to leave out, what parts to highlight, what to emphasize.
Sure.
And you're not really even thinking about it. It's just all coming out of you. You're kind of hopping from idea to idea and it's just flowing.
Yeah.
That's the cerebellum.
Yeah. No, that does sound quite important. That sounds, relatively essential.
Yeah. And on top of that, researchers are starting to suspect it's doing the same thing for the way we respond emotionally in our lives.
Think about your engagement in society.
Meaning what? Like somehow affects how you relate to other people?
I mean, it's like you're kind of understanding how I'm reacting or what I'm looking for, and you are responding with the right level of emotion. And you're also making little adjustments along the way. You're kind of putting something out into the world and you're getting a reaction back. And then you're deciding, okay, maybe I went too far with that. Maybe I should like tone it down a little. It's reading whatever room you're in and helping you attune yourself to it. And that's why, in addition to having trouble with organizing thoughts and using language, Jeremy's patient had these behavioral issues.
She could be withdrawn and flat affect, disinhibited and inappropriate in comments. And so there's an overshoot and undershoot in emotion regulation.
Had you experienced that side of it?
Yeah. Specifically with emotion, I have found myself, even in the past few months, like laughing extra loud at something, or like the reaction came out different than I expected.
Like a little bit bigger, a little bit. Yeah.
And one thing that happens a lot is I have a block where a word escapes me. So it's more nerve-wracking to have like spontaneous conversation.
Right.
And now it's like I'm kind of pulling each lever, and I have to be more aware of exactly what words I'm using, how I'm showing emotion. I have to manually do all these things that used to be unconscious and in the background.
It is kind of stunning how many different things this one little part of the brain is doing.
Yeah. It's really crazy to think that for the first couple hundred years of brain science, up until I was speaking with my surgeons about having some of mine removed, we considered this part of the brain just a motor control device.
In the West, in particular, we have thought about thinking for hundreds of years as distinct from movement. It started with dualism and Descartes and the way that Western culture conceives of, the soul as something other than and apart from the body. But that's the wrong way to think about thinking. Thinking is intrinsically related to the way we move around in the world. There's no point at which, in evolution, we can sort of validly recognize some kind of magical transition from one to the other. They're continuous with each other.
For Robert and for Jeremy too, the cerebellum represents this crucial link between movement and thinking. And they think that if you want to understand how our brains do all the things they do, like navigate language and math and logic and emotion and art in this natural and fluid way, the cerebellum is the place to look.
I mean, I think of the cerebellum as the Cinderella of brain structures. It's kind of shyly concealed beneath the cortex, ignored and its qualities underappreciated. Well, it's time Cerebella came to the ball.
You're telling us all this very helpful science, but taking the reporter hat off, how does that feel, to be learning all this stuff, knowing that it is, it's clearly so personal?
Right. Well, I think initially it felt like I was starting to understand what's happening inside me.
Yeah.
And it's helping explain why I feel this persistent sense that there's something off. And that's kind of helpful and satisfying. But then it's also bittersweet because it's kind of forcing me to dwell on what I have lost, which is this effortless fluidity that I didn't even realize I had. And as a writer who puts a lot of stock in selecting the right image and idea and word, I can't help but sometimes feel inadequate. And so I'm endlessly fascinated by the body, but every time it does come back to me and I'm put back in the patient role, suddenly that curiosity kind of disappears. And I don't know that I want to know anymore about everything that I've lost. So I kind of turn towards the science of recovery and how much we still don't know about how the brain heals and adapts after injury. We're good to go.
Great.
Wonderful. Would you mind? And that led me to a neuroscientist named David Eagleman.
Amazing. We love Eagleman.
I mean, I have to say, I'm not a cerebellum expert as such. So if somebody says, look, there's a new part of the cerebellum, I'd be interested because I didn't know about that.
He wasn't really like up on the latest research about the cerebellum, but what he'd really studied a lot was how the brain recovers after injury or damage.
Yeah, the whole system is so flexible.
And he'd found that the key to tapping into that flexibility was motivation.
Everything is about the motivation for it. If I tried to run a rehab program for you and I said, look, Rachel, we're going to teach you how to play the tuba. And you said, I really don't care about the tuba. And I'm like, no, this is great. You're going to play the tuba. You're just not going to get very far because you need the right cocktail of neurotransmitters there for plasticity to happen. And that generally maps onto motivation.
I truly have no interest in the tuba. It's Saturday, August 3rd. But what I realized was, I'm already doing this with karaoke. I don't want anybody else. And after talking to David, I kind of just threw myself even deeper into that.
I felt pretty off, but maybe I can relearn it.
I practiced at home. I recorded myself. I took voice lessons.
Just a little wobbly. Let's try again.
All right, take 2.
Let's try this one more time.
Take 3.
And shit.
I felt like if I could just get my karaoke back,
She's so soft like silk chiffon.
I would be back.
Okay, well, that happened, and I'm not gonna panic, but obviously it's not as natural anymore. It used to be one I knew pretty much by heart, so I better practice.
It was kind of like bashing my head against a wall. Like, no matter how many times I sang the song, something still felt off.
Yeah, right there at the beginning, I heard you go up and then down. It was like you're trying to calibrate to the note, up and down.
So I actually ended up calling this speech-language pathologist named Allison Hilger.
Singing is actually the most complicated, most coordinated movement you will ever do in your body.
And she told me that the cerebellum is involved in almost every part of singing.
Oh my gosh. So you take a breath. Your lung volume has to be at a certain level, not too high, not too low. If it's too high, you have too much pressure below your vocal folds and maybe you'll talk too loudly. If it's too low, you're kind of like gravelly and it's hard to talk. Your vocal folds then have to come together at a specific time. They have to be a certain tension.
Again, the cerebellum is the invisible conductor of all of these fine muscle movements.
Right.
But the thing I didn't realize until I did this reporting is that it's also the invisible conductor in all of these other realms.
Uh-huh.
So, like, think about just being on stage and giving a karaoke performance. So you're reading the lines of the song on a screen. You're kind of conveying the emotion of the song by doing your little hand gestures and dancing and making facial expressions. And then you're also reacting to the crowd in front of you. So you're kind of getting their energy and how they're reacting, and you're adjusting your performance in real time to kind of match it.
Gosh, and that's the cerebellum is boop, 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 boop. It's right at that spot.
Yeah, it's right at that interface, like right in that kind of back and forth, that like dance that you're doing with the world around you. And I feel, looking back, that it was in that fluidity and that ease that I felt in those moments that my sense of self was emerging.
Yeah.
And then now that fluidity has kind of broken down. And it's really painful sometimes because I want to like tell someone in my life how much I appreciate them or this moment we just shared together and what it meant to me. And the words just don't come out right. And it feels very isolating. Like I just have to hope and like take the leap of faith that I said it good enough that it came out close enough.
But there's you inside, Judge, feeling like, I don't think I did.
Yeah. Yeah. I think it's helpful when I can figure it out later and then like restate it when I have that chance.
Mm-hmm.
But like a lot of life does happen in these moments that you don't get back.
What do you want to figure out now? Do you have questions that still remain?
Yeah. I think I want to know, like, is the self a language that I can relearn? And just like I kept forcing myself to go back on that stage and try to learn to sing again and try to feel comfortable in a new way. If I keep pushing through that awkwardness and those moments of losing control, all these glitches and mistakes and kind of backtracking, will that ever feel like me?
So good to see you.
I'm in a choir for stroke survivors now.
Really?
Yeah, me and like...
When did that happen?
A few months ago. There's like a TBI support group that I'm in. They sent a link for this choir called Measure by Measure. And I was like, yeah, this is perfect because it's like a support group, but everyone's connected by something that gives them joy.
Yeah.
And like, I'm the only person under 70. And I clearly like recovered a lot more than most people in the choir, many of whom were musicians in the past.
1, 2, 3. Oh, the weather outside is frightful, but the fire is so delightful.
To be able to still sing after that in whatever way you can and know what would have come easier to you. To just hold like the fact that there is that kind of deep loss in life. You do have to let go of some of that, let go of like control and this image of what you should be and how it should be coming out, and just like live fully in the moment that you have now.
What did he say?
It's like people trying to be in community and like be on the same page and like feel the same song together in whatever like stumbling way we can.
Nice to see you back. Take in the miracles around you every day. Have a great week.
So there actually is one more thing that I have to tell you guys.
What is it?
When Cindy was recording me at Branded that one night, the next day I got a DM on Instagram from someone who was there, who found me by my first name and the fact that I followed the karaoke bar.
Wait, can someone just read it? Is that findable?
Do you want me to read it? Okay.
Read it.
Wait, what?
Hi, this is certainly awkward, but I noticed you at karaoke last night. In parentheses, look, there are only so many Rachels who follow Brandon on Instagram, and here we are. Well, anyway, I think maybe there was a connection, and I'm still hitting myself for not coming to talk to you then, so now I'm shooting my shot. Can I buy you a cup of coffee?
Okay, and can we read, Rachel, your response?
Bold move hitting on a girl with short hair at a gay bar. Fortunately for you, I felt the same smiley face. Thanks for doing the heavy lifting, finding me on Insta. I'm impressed enough to definitely let you buy me a drink. P.S. You had some Riz up on that stage.
What?
So
Damn.
I'm really grateful you're doing this story.
Wait, stop it. So like your singing voice, your new cerebellum injury inflected singing voice literally like hooked you a lover? What song? Or like, I mean, we have a recording of this?
So it was Objection Tango, the Shakira song. Life is funny, you guys.
Life is funny.
Get away!
Rachel. Thank you, Rachel.
Thank you, Rachel.
The one, the only Rachel Gross on the mic. This episode was reported by Rachel Gross and produced by Sindhu Nyamasambandhan, fact-checking by Anjali Mercado.
Special thanks to Thursday Karaoke Warzone at Branded Saloon, Dag Spicer, curator of the Computer History Museum, and Joanne Lowy, the director of the Singing Together Measure by Measure Choir for Stroke Survivors at the Louis Armstrong Department of Music Therapy.
Thanks also to Daniel A. Gross, Desiree Lee, Mark Gross, Brittany Aguilar, the 14 rhesus monkeys that helped us learn about the links between the upstairs and downstairs brain. And Rachel wanted us to pass on a sincere note of gratitude to Shakira.
Who, in fact-checking, we learned that her hips do not lie. It's true. If you want to learn about another overlooked part of your brain, check out our episode, Damn It, Basal Ganglia. It also involves someone getting pulled more intimately into the mystery of their own brain than they realized they would.
That's it for today. Thanks so much for listening.
Catch you next week.
Hi, I'm Brandon Beltz, and I'm from New Paltz, New York, and here are the staff credits. Radiolab is hosted by Lulu Miller and Latif Nasser. Soren Wheeler is our executive editor. Sarah Sandbach is our executive director. Our managing editor is Pat Walters. Dylan Keefe is our director of sound design. Our staff includes Jeremy Bloom, W. Harry Fortuna, David Gable, Maria Paz Gutierrez, Sindhu Nyanunsambundan, Matt Kielty, Mona Madgawkar, Annie McEwen, Saru Kari, Rebecca Rand, Anissa Vitsa, Arian Wack, Molly Webster, and Jessica Young. Our fact checkers are Diane Kelly, Emily Krieger, Natalie Middleton, Anjali Mercado, and Sophie Samii.
Hi, I'm Monica, and I'm calling from Mexico City. Leadership support for Radiolab Science Programming is provided by the Simons Foundation and the John Templeton Foundation. Foundational support for Radiolab was provided by the Alfred P. Sloan Foundation.